This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Welcome everyone to the Sunday night FRC Roundtable. My name is Scott Davis and I'm flying solo tonight. I don't have a Nightcrawler co-host student with me tonight, so I'll be doing the intros. Welcome to the Roundtable. My name is Scott Davis. I'm a mentor with Team 2052 Nightcrawler. And a few housekeeping notes before we get started. The Roundtable is recorded for YouTube and Spotify. You must be 13 years or older to participate in the live call. If you're comfortable, we ask that you please share your cameras while you're speaking. The Roundtable is no longer exclusive to Minnesota teams. Mentors and students from all FRC teams are welcome to join us. And for more information, you can see our website at 2052.com/roundtable. And you'll find more information there about how to join the call, how to join the mailing list, and see our complete privacy policy. We'd like to start off the call this year with something called What's on the Wiki. And so tonight's topic, if I can share, oh my goodness, there we go. I think I want this one here. I should have practiced this ahead of time. Can you guys see that? There we go. So tonight's call for What's on the Wiki is, this came up because last 2 weekends ago, we participated in something called mini trials here in Minnesota. And I had two different teams come up to me and ask me about this. They wanted to know what accounting process we used for our 501c3 nonprofit. And so coincidentally, I had prepared training for accounting process years ago when I took over the accounting process and I built a new accounting system for us. And so if you are interested or you suffer from insomnia, there are 5.5 hours of videos on YouTube about how I built the accounting software and then how to run it. Primarily, I built this so that the next person behind me that would take over as treasurer of the nonprofit would know how to use our books and how to run the books if they wanted to continue using the system I got. This includes reasons why you might do the system for visibility to the board or to all of your mentors, and ways that you can protect student privacy and other things that are important to robotics-centric or student-centric nonprofits. So that is what's on the wiki. So let me go back and stop the share. All right. Tonight's call is being hosted by Talon Robotics. And Allie, you have the floor. The night is yours.
Thank you so much. I'm going to share my screen. So, good evening, all of y'all. We are Talon Robotics, Team 2502. I am Allie. I am one of the engineering captains, and I'm presenting with a few other members of my team so we can talk about how we train our students for a future in engineering. Let's see if I can make the slides advance. Oh, darn. Perfect. There we go. My deputy, which we will explain our leadership structure soon, who was going to present this, he is not able to connect to the meeting, which is not ideal. Brooklyn is another one of our deputies. Brooklyn, are you interested in presenting this?
Yes, I can cover this. So our team, we have around 50 registered students and 22 mentors currently. And we operate all year round, just like most teams. We have a lot of we operate with sub-teams that we'll get into later. But the whole point of our team is that all are welcome. We are student-led, mentor-guided, of course, and anybody can join. There are no tryouts. There are no hoops you have to jump through. We'll have anybody just pop into our open room, which is why we have open rooms up until like 9 most days, so that anybody could pop in after an activity they have, or if they can't come until later, anybody can come. During our off season, we only have an open room about once a week, but we host a variety of events all year round. And what we'll get into in this presentation is how we have changed our engineering structure to better fit the needs of our team.
Thank you so much, Brooklyn. Sorry to put you on the spot. So I'm going to talk about how our team was organized in the past. So this was our team's organization as of last year when we presented this roundtable on training last year. So our team is, we can just go through the diagram. So we have a head mentor and a purchasing and financing mentor. So our head mentor, Ellie, is here. Hi, Ellie. I'm so happy you could make it. Our team is split down the middle into a business side and an engineering side, just so that we can have all elements of what makes a robotics team run, because, well, it is fun to build a $15,000 robot. You do have to raise the $15,000 and all that. And then, so on engineering, last year, we had it under 2 captains and then under 5 sub-teams. So we had design and CAD, which were the digital design or testing of the robot and getting all parts of the robot planned and figured out before we built it. Then we had the electrical subteam, who would meet to plan out the electrical of our robot and train everyone on how to safely use all electrical tools and the best way to wire a robot. Our programming subteam met weekly through more of the year than the rest of our subteams in order to train everyone how to use our programming language of Rust, which not a lot of people knew. And then we had safety and organization, with the hope of trying to make sure people don't get injured while at robotics. And then we have scouting and strategy, who coordinate the software and plan out all elements of scouting at a competition. So that had worked somewhat in prior years, but there were some issues that led us to choose a different organization for our whole team as of this year. We hope this will help us to be a more competitive team and a more sustainable team, and so we're going to share the changes we've made. So there were some things that weren't working with our system. So with that system we had there, one of the first issues we had was with integration and troubleshooting. Let's see if I can get the slideshow. There we go. So by having different parts of engineering, like having software engineering and electrical engineering split off without much intersection between those things, finding ways to make problems work, figuring out what hardware to use, wasn't always the easiest problem to solve, because we would have issues because each of those were on totally different corners of the team. The people with those expertises were being in the room on completely different days. So there were some issues with our robots that we were struggling to solve because of how we'd separated our team. And to add to that, the way we organized our team to have the people in leadership being requested to have this one very specific expertise meant that it was difficult to train people to know all of the things they needed to know about robotics, because they were being encouraged to be pigeonholed, kind of, into this one very specific thing. When in robotics, you need people with a whole range of different things. And that means that when you're one person with that expertise graduates, as students do in an organization, you are left with it being very hard to train the rest of your students. And with a large group of graduating seniors on our team, we found that that was going to be a big issue. And we had one last issue with our organization: efficiency. Some of our sub-teams weren't working too well as a sub-team. First, prioritizes safety over all things. We need to make sure all students are safe. But for our team, it wasn't working the best as a student-led sub-team because the safety of our organization and all of our policies shouldn't rely on a student. So we decided that we might need to change that. So, I believe Brooklyn is on deck for presenting our new organization of our team, which is how we tried to solve these issues on our team.
So we kept our business side more or less the same, but on our engineering side this year, we decided to implement a student engineering committee and a mentor engineering committee. So what these would do is our student engineering committee was split into 2 to 4 deputies, which would be more all-rounded. They would have a set of goals together, responsibilities that they would split up together, and they wouldn't be split up into different sections of the team. Now, they can have specialties, things that they specialize in, but they weren't completely separate leads. And our engineering committee is pretty much the same thing. We'll have specific specialists, but they won't be completely split, just like our students.
We are hopeful that for the next season, this will make it easier to solve some of the problems we had issues with in the last season. But we just wanted to talk with y'all about all of the teams here. So what your team structure is, specifically relating to the engineering part of your team, the robot building part of your team, and how you divide that, because we want to know like how you distribute tasks and whether it causes any issues on your team. So if any team would like to hop in on how they organize that, we would love to hear your opinion.
I guess I can go first for Nightcrawler. I was looking through the attendee list. I don't think we have any Nightcrawler students on the call tonight. We've had a very busy weekend of fundraising, so I'm hoping they're all doing their homework. So we divide our team basically into 3 main sub-teams: business, program, we call it More Than Robots, which we've shared that name from another team who's probably on the call tonight. So More Than Robots, which is our media and awards and things like that. And then we have our programming sub-team and our build sub-team. Our programming and build sub-team work very closely together. So at the beginning, after kickoff, for at least the first week, our build and programming students work together on design ideas, strategy ideas, game ideas. And then when they start to break off, we go have the programmers start coding everything that's sort of been discussed, knowing that a robot probably isn't going to have both an arm and an elevator. But the idea is that it's more code. So we get more people writing code, which is good for skills. But then also, as soon as we have an elevator built or an arm built or whatever gets prototyped, hopefully we have code that can be tested very quickly. So our programmers check in with our builders quite often and kind of peek over the shoulder and see what's happening so that they can continue to write their code as prototypes are being built. But there is definitely a separation there, which may be a little bit more of a separation than what you've shown in your slide there. So do you have questions that you want me to clarify before we move on to somebody else?
Just for a little context, could we ask how many students and mentors your team has and how many like leadership positions you would have covering that?
Sure. We started our fall season with 75 on the roster, which then got cut down to 64 if paperwork and permission forms and things like that weren't turned in time. We have made the decision that we are further going to cut our competition team down to 50, which is what our team was last year. 51 was what we had last year. We ran into issues with having not enough work for all of the students to do. We are planning to build both a competition bot and either a kit bot or a similar competition bare bones type of bot, like West Coast Products kicks out a design, and somebody else does this too. Robonauts, I think, have their kit bot type of thing. So we're planning to build 2 robots. We have broken our season into fall season and then winter spring season. And so everybody can be part of the fall season. Everybody comes in. You have to participate in the fall season in order to be part of the competition season. And then we choose our competition team based on a point system, which I brought up a lot in this call over the years, attendance, grades, things like that, determine whether you make it on the competition season, seniority, your role in the team, things like that. Mentor-wise, at any given meeting, you will probably see about 8 mentors at a Nightcrawler meeting. I think we probably have double that, but we have more mentors that can only come once or twice a week compared to those that can be at every meeting.
Thank you so much for sharing. Do we have any other teams who can share about their team structure, specifically their engineering side?
If we don't, I'm happy to share some of the ones that we've done before these last couple, but it sounded like someone was trying to speak, so I'm gonna be quiet.
No, that's okay. You can go.
Yeah, go ahead.
No, I just have more like talent structures that we've done, which our team is fully aware of because we've talked through it a bunch. So what do your teams do?
I'm from the Emperor's Team 3926, and we do something pretty similar. We have we're divided into engineering and non-engineering. Our non-engineering part is now called the operations team, and they do everything, all the fundraising and social media and graphic design, all that stuff. And then engineering, we have split up into 3 sub teams: builder, mechanical, and then code. And we have split off the control systems or electronics into a separate team, but they work very closely with the code team. And they're really sort of like 1.5 teams. There's a lot of overlap there. And CAD is not really a separate team for us, but we're doing some, I don't know if I would say we're doing some reorganization this year, but we're doing some trying to improve our systems so we have better coordination between the teams and better communication, that sort of thing. So we're not all siloed as much as we have been. It hasn't been an issue some years it has been. Last year it was an issue, and that was the number one thing people said was we need better communication and more organization. So
Thank you so much. It's interesting to hear about how you had some of the same issues we had. Can I ask, like, if you're willing to share, what were some of the issues specifically? Like, one example from our team was getting our robot positioning to work was an issue because that required like working with both electrical and with programming to figure that out. And as we had those split, we weren't able to coordinate that as well. So with your groups, like what was an issue you had with your 3-ish groups? Like what wasn't coordinated there?
Trying to think of a good example. I don't know if this is the greatest example of a lack of communication. This might be more of a design question, but several team members quickly got enamored of the idea of having a climber that they saw on Robot in 3 Days that had a hole in the middle of the robot. And putting a big hole in the middle of a robot gave us very little real estate for doing things like electronics. And that made the electronics crammed and difficult to work on, difficult to modify, update, repair, that sort of thing, and that made it just made for some challenges. I don't know that that was a communication issue as much as that was a design decision that some of us maybe wish we had gone in a different direction. So I will say, as a fun aside though, because we are the emperors and our mascot is a penguin, we always try to have a Arctic theme name for a robot. And one of our team members found out that there is a Russian word, Polonia, which means hole in the ice, where penguins actually fish sometimes. And so our robot last year was called Polonia, which was a beautifully accurate name for a robot that actually didn't do very well, sadly.
Thank you so much for sharing. That's really helpful to know. Clay Hansen, you had your hand up. Do you want to share next?
Yeah. First of all, I think that's a great name for a robot. We should name everything after penguins. No Mythic 2491 that I mentor with splits our team into historically build, programming, and operations. And starting this season, we've split it into build, programming, operations, and strategy. There's a contingent of students and mentors who have decided that like there's an important component to, there's enough like meat to chew on, so to speak, in the like both micro and macro strategy realm to dedicate a better part of the season and preseason to that sort of work. Something that I've been interested in finding better ways to bridge the gap between is the build and the programming team, which I feel like exists in the like electrical realm, electrical / mechatronics, right? Like you can build a robot, you can program a robot, but there's this like, a bunch of copper in between the robot frame and the robot programming that has to like behave correctly, and building a institutional proficiency around getting that copper to behave is always a challenge. Things like wiring proficiency, how to do safe crimps, how to make a CAN bus network that doesn't get that is resilient against damage and interference, etc. And how to insulate against the minor foibles that result in a robot that stops running on a field. That's something we're sort of playing with, is how do we find a middle ground between the programming and the build team, the like mechatronics team, right? The Magic Pixies team. So I'm interested in hearing if anybody has had any success in bridging that gap.
Thank you so much for sharing. Yeah. Talon had an electrical sub-team that was mostly for that training, but it still didn't really bridge that gap between programming, electrical, build, and that was why we changed it. Yeah. Stacy Foreman, I believe you are next in sharing. Would you like to share?
Yeah, we're trying to work on my camera here. I'm with a finance mentor for 2472 Centurions, and something that we've done in the past couple of years, noticing some of the differences or the maybe communication gaps or lapses, is that we have instituted a systems engineer position, essentially our vice president, and they are the ones that are working with all of the different, checking in with all of the different sub teams. We did combine for this season electrical and mechanical into one group. It's something that will be new for us this year. And then we also work a lot with, from a task management standpoint, we've been using GitHub and an Agile system that the students manage to divide out the tasks. And then every 2 weeks, we're roughly connecting the entire team in leadership on every time we meet, there's a little recap session at the end. So the different leaders are informed of what's happening and what kind of the roadblocks are. So that helps increase the communication amongst the students, so they know what's happening, what the expectations are, and if we're on track or off track from whatever goal they set for that sprint.
That sounds like such a cool position you have. That seems like such an interesting way to run a team, and I hope at some point, perhaps next year, we can hear more about how well that worked for your team, because that just sounds so cool. Scott, you have your hand up?
Yeah, I wanted to bring up, so you had asked, I think maybe after Clay had spoke or maybe just before, about if you had electrical as a separate team. Nightcrawler used to try to have electrical be part of programming when we called our sub-team the controls team, which I think is exactly what No Mythic is calling theirs. We moved electrical back, or I shouldn't say maybe back. We moved electrical into the build team for a couple of reasons. One was that the build was doing most of the wiring anyway, because the programmers were busy trying to get the code done. Two was that we have, at the time, 2, and now we have 3 electrical engineers, but they're all build mentors. None of them are programming mentors. So it made sense that if you're going to have people who know electrical stuff, then that's the people that should be leading the people doing it. But I think we also found that where to put sensors, and it was primarily around the idea that your programmers are in charge of saying we need these sensors, and so they should be in charge of those sensors. Where those sensors go largely have a pretty significant impact on how you machine your parts or where you can route the wiring. And so the build people care a whole lot more about where the wiring is going to go than the programmers care. And so we needed to put that responsibility back in the hands of the people building the robot so they could also be planning on where that goes. Now, what that does mean is that you need your programmers to say, hey, we need 2 sensors for this mechanism. And they need to say that earlier. And so we put an emphasis on doing better communication. We tried an integration captain once, I think way back in maybe 2017. It takes the very, very right person in that role to be successful in that role. That's a very hard role to train because it's not about knowledge. It's more about skill, leadership, charisma, to bridge the gap between those 2 groups. So that's a really hard role to do, but if you can find the right person, and I think Centurions has found that right person for their integration captain or systems integration captain, it can be great. But we've done a better job as mentors of prompting our sub-team captains to go talk to each other when something comes up, saying, hey, you better go tell Build about that, or vice versa. And so that's how we've sort of solved that problem of where does electrical live, and this issue with maybe having an integration captain versus not having one.
I think something that I witnessed when I joined No Mythic a few years ago was a bit of a what seemed like good-natured competitiveness between sub-teams. Build team saying oh, that's a programming problem, and programming, harping on Build for not building a robot they could program, but shifting that narrative to a hey, we're all rowing the same boat, we're all working towards the same goal, and the dynamic you want to build is one of how can we make this easier for our teammates? How can we be proactive in engaging with the programmers to say, hey, I assume you're probably going to want to know where the note or the coral is. Do you want to know when you've got it? Here's what we can offer you in way as a matter of sensors available to, do you need to know exactly where it is? You just need to know yes or no. Trying to bridge the gap, during the season, often our programmers are in a different classroom than the build team. And so there's a little bit of physical separation that can sort of create a more organizational separation, just because it's hard to program in a room where there are saws and machine tools running. Any effort to make a build student more curious about what a programming student is doing and vice versa, that all seems to pay off in spades. I've always thought, so I'm an engineer by trade, and the most dangerous engineers I've ever known are mechanical engineers who can write code, or electrical engineers who can wield SolidWorks or Onshape, or any combination, a double or a triple threat. And so the more communication you can build between sub-teams, the more effective those teams all seem to be.
Thank you so much. Mark, you have your hand up. Do you want to share?
Yeah. I was just going to piggyback on not what Clay said, but what Stacy said, that we have also started an agile sort of system, which two of our mentors knew about, and they have spearheaded it. So they are now training both mentors and students now on how to do that. And so we've also been doing 2-week sprints through the fall. When we get to the build season, we're going to do 1-week sprints, which is sort of sort of cycles of setting goals and getting together and making sure that everybody's on the same page and communicating with each other. And it's a way to make that more to ensure that the communication is happening on a regular basis and in a structured way. And so far, I think it's got a lot of promise for us.
Those sprints sound like such an interesting system that Talon might have to try at some point, because that sounds like a great way to make build season go a little bit smoother and a little bit more as planned.
Well, talk to us later in the spring, but I think I think you probably have to have the right mentors to run it, who have already had experience with it in industry, so they can bring that experience in.
Yeah, we'll definitely talk to our mentors, but thank you so much for sharing. Lisa, you have your hand up?
I do. I wanted to go back to Scott. You mentioned the way that your team is divided. Your programmers are actually selecting the sensors you use, but your build team is actually doing the wiring of those sensors and the placement of those sensors. And I'm curious how that works for you, because I mean, every team, every engineer is always going to have a problem with how much do you silo and specialize, and how much are you interdisciplinary, and how much do you create this problem, which is a good problem, of having maybe a really wide breadth of knowledge that's not very deep, which is actually great for leaders, but it's not necessarily great for doers. But it depends so much on the people, and we find that with few mentors, we have to change our strategy every year, kind of based on who's on the team and how they're interacting with the team. So all these different paradigms are very interesting to me. Our team did have basically a small team. Everybody was interdisciplinary. Everybody wanted their hands on everything. And that disappeared way before COVID. And now we're trying to slot people more into a specialty, at least for the fall, with training. So we do have a completely separate mechanical, completely separate electrical, completely separate programming. And pretty much the mentors are picking up the weight for the operations and all of the everything but robots. But electrical finds they don't have much to do. It's a lot of rote, it's a lot of practice, it's a lot of, okay, you tell me what you're going to do. So our electrical team has been specifying what those sensors may be, how we can use what as a switch, where we can put it, how we can modify it. And I've heard some teams say that their electrical goes with build, and some say their electrical goes with programming, but you seem to have a hybrid, and I'm just curious how you came up with that and how that works for you.
And when you say you're directing that question to me, Lisa?
I am.
So I'll give you an example. We'll say the programmers will say things like, we need a limit switch at the bottom of the elevator, because if we hit a brownout or reboot in the middle of a match, the elevator is going to zero wherever it's at. So we need to be able to have a way for our secondary driver to run the elevator down very slowly until it hits that limit switch, so that we can re-zero the elevator. how that limit switch gets put on the robot, where it goes, the best place for it to be relative to an elevator design. Programmers don't care. They just need to know, is the limit switch on or is it off? And so they share with the build team of, we would like to be able to zero the elevator mid-match. And we think the best way to do that is limit switch. Now, the build people might say, hey, there's a better way. And that's great. But that communication sort of happens there. Most of our sensors are beam break sensors that we've used in the years past. And so it'll be things like, hey, we need to know when we have a ball staged here, and we need to know when we have a ball staged here. Or it may be something like, we can only load the note so far forward, and then we have to stop loading it. Otherwise, we can't spin up our shooter because it engages the shooter wheels. So it might be things like that. And so the programming and the build team will agree what are the goals of a sensor, and the build team will be responsible for sort of getting it in the right spot. And sometimes it'll need to be moved as we do testing. And the programmers are responsible for reading that sensor and making the robot behave the way that it needs to behave to work. Something else that you mentioned that I think is really important is about, there's not a lot of stuff for the electrical sub team to do. And we definitely ran into that as well over the years. Things kind of get wired as they get put together. And a lot of times that kind of thing can maybe even happen at an optional meeting. And so we never want to hold up progress because the right person from the electrical team isn't available. And so we have a variety of build sub-team students that know how to crimp wires and know how to connect ferrule or put ferrules on wires and put them into the electrical system. And then almost nothing happens on the robot from a wiring point of view without a mentor's supervision. We might have a captain who's been on a captain role for multiple years that may supervise some of that stuff. But I think a lot of teams here will share stories about how the reason why their robot did not do something in competition is because a wire came loose. And we've learned that lesson the hard way too many times. And so we always have a mentor sort of over the shoulder watching, and then we usually have at least another student and maybe another mentor sort of double checking the wiring as a result of that. So not having a electrical team is less of an issue because we have an electrical process that has a bunch of double checks, and we can put most of our build students on a task and with some, maybe even some on the job type of training to get something put together so that we can keep moving forward. It's a sort of an ad hoc system, but it's actually let us move faster.
Well, thank you. So it sounds like the programmers aren't necessarily specifying a particular sensor, but they're saying in the code, we need a signal here to make our code effective.
Absolutely. And oftentimes what the students don't really care what type of sensor it is. They just need to know, I need to know that the ball made it here, or the note made it here, or the elevator is at this position. And so oftentimes the programmers will say, I need to know if the intake's in or out, or I need to know this. And they'll work with the build team. And usually the build team will say, oh yeah, we've got a couple sensors that'll work great for that in the tool chest. Let's pull those out and try them. So we don't have the programmers dictating what gets put on the robot. We have them sort of dictating, hey, if we want to be able to recover mid-match from XYZ, we need to know this. And usually the programmers will ask for a limit switch or something, and the build team will say a beam break will be a better option, something like that.
Thank you so much, y'all, for that discussion. It was really interesting to hear about how you were able to distribute different tasks and what issues arose. So I'm going to move on to our last discussion slide before we move on to our next half of the presentation. So if any team has any last things they want to share about this team structure and team division and what works best, and if there's anything they'd want to change, this is just, if any teams haven't shared yet, but they would really like to share. If someone has one more thing they want to say, this is the perfect time.
I'll jump in. My name is Ellie Feist, and I am the head mentor of Talon Robotics. Shout out to my kids for putting this presentation together. Talon Robotics has tried a lot of different strategies for our leadership structure. We've gone from like one president overseeing everything, one president and 7 different captains, to kind of maturing into this kind of like structure that it's been consistently. But that's just what works for our team. That doesn't necessarily mean it is the right way to do leadership. All of these leadership structures that were discussed are phenomenal. And whatever structures other people have are also great. Our goal, having been on the team when this structure was created, was just trying to get as many student leaders in a position of leadership as possible, just to make sure people are having that experience. And with such a large team, that works for us. However, a 10-person team isn't going to be able to operate with the same structure we have. That's just not going to work. So a lot of it is just trying and figuring out what's best for you, and then being willing to adapt, and take that step back and be like, we're not going to blame people, but how do we make improvements moving forward?
Thank you so much, Ellie. Now seems like a good time to move on to our next topic for the day, which is training. So I will be covering how we've done training in the past and how we've done it this year. So we'll start with last year's system, the same as we did for organization. So for training, last year we had some summer trainings. Summer trainings last year were a little interesting as we did not have access to our primary build space and we were in a random English classroom. We did whatever trainings we could, and so we didn't have as much training as we wanted, so we decided to do training month. In training month, we had 2 to 3 hour long workshops. They were typically directly after school, as that is when we get the most participation from our team. And we decided to have all of them be, the first half is a lecture, and the second half is a project. And because that is what we decided would be the best way to teach a wide range of people. And they were 5 days a week over the course of the entirety of September. And then we also had mini trials. We had 3 mini trials team last year. And so to do mini trials, we had robotics 3 days a week, 3 hours a week, also directly after school, as that was when we could get the most people. So that was how we did training last year. There were some things that went well. There were also a few issues. So last year, so 2024 season crescendo, new members were better trained than the year before that. And new members seemed to be retaining information fairly well because we had those projects. We had mini trials. It was a lot better than the kind of random, disorganized, like, ooh, maybe we'll teach the freshmen how to do that today. Like, it worked a lot better than the kind of scattered ideas we had previously. But robotics, every single day, 3 hours a day, overlapping with other events, wasn't the best way for our team to do training. So due to that huge, amount of training, but not actually having people able to come every time, we ended up with not being able to train people in design and CAD as well as we would have liked, which wasn't ideal when immediately after that was mini trials in which they would show off their design and CAD skills that they hadn't been able to learn. And 3 hour time slot was also not ideal for our team because this training month was the first time that our new student leadership, these were their very first meetings. And as one of those students, it was a little difficult to figure out what to teach for 3 hours when you'd never run a meeting before. So we decided to change a few things going into this year, just to make stuff work a little bit better for our team. So here's the schedule, our September schedule for our team. So training month, rather than being every single day, was 3 to 4 days a week, and the meetings and workshops were of various lengths. We had some days where you learned for 30 minutes, and then we've just got open time to work on projects. And we had some days where you learned for an hour to 2 hours on a specific topic. It wasn't the same thing every time. We had some students run projects, we had demos, we had presentations, and they were scheduled anytime that was free during the week, so that as many students as possible could attend, rather than overlapping with other events. Mini trials, we reduced it down to 2 teams in the hopes that they would each be a little bit more successful than each of our 3. And we kept the same open rooms. We just decided to swap some of the days around when we saw that people weren't able to come. And we just wanted to mention, so a lot of our students come into robotics with prior training because Eden Prairie hosts 5 FTC teams, and they are in our high school's build space on alternating days with our high school team. So many of the students in our robotics team already know how to build with the tools in our build space, and many of them are also FTC mentors, so they already know how to teach people how to use the tools in our build space. And as my co-captain is probably raising her hand, we also run a large FLL program with 4 to 5 FLL teams, and many of our team members also train them and teach them all those engineering skills. So that is another way we train people. Let me change the slide. The main lesson we learned, 30-minute trainings. We would not recommend them. The 30 minutes right after the school day ends and everyone's running down to the robotics room to see all of their friends. You can't teach 8 to 10 people how to use a variety of tools in those 30 minutes. Because what you'll actually have is about 15 minutes. And then when everyone has to go off to all their meetings after the end of the scheduled time, you end up with, well, you've signed off 1 person on a drill. The other 8 people in line are trickling out the door. So we would not recommend that. I know I've got my FTC lead and a few of my deputies on the call. Do any of y'all want to hop in with any of the things you learned?
Well, I'd say on the topic of 30 minutes is too short for training, especially on the topic of training people on tools. I'd say what we have learned is that it was a lot easier to get people signed off on tools by doing stuff like projects and mini trials. That was an easier, I'd say more natural way to get people to learn about tools, their applications, and to get them signed off. And it ended up taking less time than dedicating such a short time to signing people off on tools.
Thank you so much for sharing, Brooklyn. I just remembered that I have pretty little slides for some of these things to discuss, so let me pull one of those up. Okay. Does anyone on Talon want to talk about how we did how mini trials worked in training, y'all? Because this year we tried to do mini trials better than last year with fewer teams to dedicate more resources to each team. We also had dedicated mini trials team leads this year, which were our deputies, and we had mini trials student mentors dedicated, which were our team engineering captains. That was how we organized our mini trials teams to best teach people. If someone on Talon could share whether that helps them learn at all, I would love if we could tell other teams about how we used mini trials to train.
I think that having our like leadership team teach us, like now that we don't have like a specific electrical or a specific CAD person, then it didn't really matter much about who was in room because everyone had a good enough knowledge to get started on our robots. And it was, yeah, I guess it was a lot more, it was a lot easier for everyone to get signed off and learn when or why we would use a specific tool rather than just, hey, this is how you use the horizontal bandsaw. You're going to use it in like 2 months. I hope you remember.
I think this year it was better to have smaller teams because that way we could also spread out more people across the teams to help out. Whereas last year in 2024, I feel like we had not enough people just dedicated to teaching the teams. And so it was kind of all just a lot of people who needed help were going to the same person, and that person was just super overworked. So I think it was better to have like deputies spread out and captains spread out so each team could have someone to go to without putting too much of the load on one person.
Thank you so much for sharing, all of the people on Talon. I know several of the other teams here on this call used mini trials as a way to have another off season, as a way to train a lot of their lower classmen. Can I ask any of y'all who did mini trials, how has that been working for you for training?
This is Tim Dare with Ultraviolet, and we've actually gone to about an 18-month training cycle for people that are using tools like CAD and Java. So what we do is when the freshmen come in, safety training is immediate so they can start doing assembly, working with the machine tools and things. And then it is after our first competition, we try to do week 1 every year, that the new people actually have a context. They understand why they might want to become a designer, why they might want to become a programmer. And in the interim, 4 or 5 weeks, that is a great place to get them going on CAD and on programming and on wiring, you name it. They can get traction. And for tools like CAD and Java, I mean, you can do it after hours. That's what the time between 11 and 2 in the morning is for. So they get a toehold. They, based on their personal motivation, can work on it through the spring and summer, maybe tutoring others. And when mini trials comes, that's prime time for them because they're the modelers, and the new round of freshmen are the people who are actually doing the assembly and prototyping and plywood and those kinds of things. And by the time you finish mini trials in your second year, you're ready for prime time.
That actually sounds like such an amazing system. Thank you so much for sharing.
You're welcome.
We have 2 hands up, one from Clay and one from Scott. I believe based on the lovely little Google Meet, Clay, you had your hand up first. Do you want to share?
Only just by a hair. Historically, No Mythic has turned the freshman students loose on mini trials with like a bare bones crew of guidance from sub-team captains and a couple of mentors, and let them sort of get their feet wet in all of it. This past season was an exception. Or this year's mini trials was an exception to that because we had a very top-heavy team last season, and unfortunately for us, and very fortunately for them, they all graduated and went off to the next part of their lives. So we tried something new this year. I gather this has been something we've done in years past, but prior to my time on the team, is to turn the whole team loose on mini trials, and I think it was the right choice. A lot of students who were just newly this year stepping into leadership roles, who were just newly stepping into any role whatsoever, and it was a great opportunity for students to find their voices, to figure out what it meant to coordinate a larger group of students rather than just being focused on your own little tasks. It was a a great opportunity to sort of iron out some kinks before the season started, to identify I won't say weak points, but like opportunities for growth. Like, oh, we've identified that our system as it stands right now is weak in this way, and here's how we should augment it before the season starts. There have been a lot of conversations that have come out of mini trials about deeper level organizational stuff, putting together bills of materials and CAD consistency and manufacturing processes, the sort of things that a lot of students this year, a lot of the students who are in leadership this year sort of assumed were just magically happening last year, but were actually happening because of our senior students, Monster energy drinks, and gas station donuts, which I believe is what fueled all of those students. So.
Thank you so much. That last part does sound scarily similar to our team, as there's a gas station within walking distance of our robotics room.
Yeah.
Scott, you have your hand up next.
We do mini trials. I think this is the third year that we've done mini trials this year. Our students would revolt if we didn't do mini trials. It's one of their favorite parts of the fall and has been the best training that our team has ever done, certainly in the 11 years that I've been with the team. We are very much sort of a hand prototype type of deal. We did not do any CAD this year on our mini trials bots. Last year we had one student learn CAD. She CAD'd up shooter plates for the beach balls, and we did actually end up using those plates on the robot. She was learning CAD while she was designing the plate with a veteran student sort of over her shoulder, helping her do those things. It did slow down their team quite a bit, but they did end up with a very well-performing robot in the end. It also took away sort of hands-on time on the robot for the other students while they were waiting for the CAD to get done, for the plates to get cut. So there was both good and bad there. This year, the students decided that they didn't want anyone learning CAD unless they understood sort of more the mechanics of a robot, like what a motor is, how belts work, things like that. And so we had decided to hold off on CAD to make sure all of our new students had some hand-on experience. I think we are going to probably not do that again. CAD takes a long time to be proficient at. And one of the problems we've had in the past is that students that didn't start learning CAD until December really weren't proficient enough to contribute on the competition bot. And so they ended up spending all of their spring basically in training and not actually getting to design parts that were on the robot. You can mitigate that a little bit by saying we need to redesign. For example, last year with the cage climber, we did a redesign of the little fingers that went out to corral that cage. That's a simple enough thing that you could drive over the shoulder and help a new student design those new finger plates and things. But I think I'd love to hear what other teams are doing if they are able to get new students into CAD and working on competition bot parts. I'd love to hear when they're starting CAD, how they're doing that with their new students learning CAD, because I would really love to have our CAD students making sort of like with programming. Our programmers come in and they are coding from basically day one. They do some mini trials prototyping, but then we send them back to CAD, and we have a very structured kind of learn how to write code in the fall. And nearly all, it depends on if they show up to all the meetings, but nearly all of our new programming students get code on the robot. I love that for our CAD students, but there's this conflict of, do you know how to like turn a wrench before we let you have CAD, or can you draw things that are impossible to build? And so there's this balance of how do we figure that out? And I'd love to hear what your Talon is doing in that regard and how other teams are handling that for training.
Before Ellie and Clay talk, as they both have their hands up, I just want to mention, and we can talk about this later, but Talon did have a variety of parts on our mini trials robot CADed, as we had the goal, like, as you said, it is hard to have students work on CAD of the robot during the season if they don't have practice doing that prior to that. Like, the best way to learn how to build a robot is to build a robot. The best way to CAD a robot that is reliable and can be machined is to design a robot that works and machine it yourself and all that. So we did have mini trials robots with all of those parts. We had one team that had pretty much their entire robot CADed before they got all of it built. We had one team that kind of built and CADed as they went. But that was really helped out by our FTC and FLL programs that pretty much every student joining our team already knew how to build at least some semblance of a robot, just because they'd already been mentored by Talon high school students for many of them for 2 to 5 years already. But we also have students from all levels who are happy to hop in and learn that. So, yeah. Ellie, you have your hand up. Do you want to share next? And then Clay can?
Yeah, I'm just real quick. I have been involved with Talon Robotics for almost 12, 13 years, being a student, alumni, and now mentor to head mentor. And many trials is the best thing that our team has ever done. Just seeing the engagement and retention rate skyrocket, even for us just doing it the last 2 years. And it's a good chance for us to understand how our students work and how they learn. So like we as mentors, like at the mini trials competition, we're like, okay, so these are how our like students think. This is how we're going to be able to help them solve problems during the season, because now we've seen it. And the one thing I kept reiterating the whole time we were at mini trials is like, it's supposed to be frustrating, at least the way that we do it. It's supposed to be like learning the lessons the hard way in a way that's not during the season. So that way they get that experience. Like this year we had both of our teams on the field together and both of them e-stopped at the same time by hitting the space bar accidentally to get the screen to light up and like remove it from sleep, but then e-stop the robot. And that is frustrating to watch and to be in the situation. But I also could guarantee you those students are never going to make that mistake again. So it's good to like, it is a frustrating competition just because you want things to go well, but understanding that the point of the conversation or the point of the experience is that it is frustrating and it's supposed to be just full learning. And as long as I'm on the team, we will never go back from any trials because it's just been such an incredible experience. So we love it.
Clay, you still have your hand up. We would love to hear you share.
Something that we're trying this year with No Mythic and potentially with Inconceivable, and maybe other teams if they're interested, is a there's a YouTuber whose handle is Too Tall Toby, which is a great name. Essentially, it's like a CAD speedrun challenge. It is a means of like racing to finish a model. Like you're given the engineering drawing for a 3D model and you finish it as fast as you can, and then hit the button and clock your time, and your time gets logged in a like global leaderboard amongst anybody who's tried it. And we started, I sort of had this realization like, hey, we should try this, but we don't have access to all of the models available through that Too Tall Toby system, which understandably requires a $5 to $8 a month subscription, and I can't expect that of our students. But decided to essentially recreate the same thing because No Mythic and Inconceivable and anybody else who wants to participate has probably a whole bunch of CAD to work from, right? We've got several years worth of robots in Onshape, and even more if we look back into our SolidWorks archive of parts to work from. And the idea being, hey, let's motivate our students to like, I guess the word is speed run CAD, but like compete to do things faster, compete to become proficient in these languages, this CAD programming language, right? Like the Onshape. I mean, it's not quite a programming language, but it is. You are creating things with a series of hotkeys and interfaces and functions, and motivating students to learn those skills and to learn to use them with efficiency and quickness. That like the best time to learn how to do that sort of thing is before the season starts rather than during, right? Like you would not expect to walk onto a soccer pitch and be really good at soccer and start playing right away. You do a bunch of drills, you do a bunch of, you practice taking shots on goal, you practice taking corner kicks, you practice taking, doing all sorts of things, and then putting those all together when the season starts. So that's one of the goals this year is to like motivate, to like gamify, I suppose is the word, students and mentors alike, and students beyond the build team. Like operations students would benefit from knowing how to do CAD as well, so they can design like swag to give away at our pit, and like things to fundraise with, and programmers might want to build their own button boards. Essentially, like how can we like cast a wide net and drag a lot of students into being as competitive as they feel like being, to figure out how to do CAD quickly rather than learning on the fly in the middle of the season.
That sounds like such a cool system, and I'm so excited to hear how that goes, because that sounds like an absolutely amazing way of teaching some of the CAD skills that teams need in order to make the best robots they can. So thank you so much for sharing.
I posted a link in the chat to this bare bones interface that I put together, and I'm hoping to populate with CAD or with drawings from a variety of themes. If anybody's interested, reach out to me here or via email, and I'd love to make that work and get people interested in doing CAD quickly.
Clay, will you also put your email in the chat as well?
I suppose if people are going to email me, I should probably put my email in the chat. Yeah.
Lisa, you have your hand up. Do you want to share next?
Well, actually, I have a question. Several people alluded to training. Obviously, we're trying to do our best to train people. I'm just very curious how people are doing that training. Do you have kind of a series of badges or curriculum or lectures that you have in a bank that you use? Can students self-study from some of those modules? Are you relying entirely on the job, in the moment training? Like we have this problem right now. How are the ways we can approach it? How's that working? Because I know for us, we are always struggling with how much basic kind of training that we want to do, because we know that people want to have their hands on the robot, and we know people want to get the robot to move and do what they want it to do. But we still have to back up and fill in the fundamentals. But we don't have a good archive on our team of how to train people in the same way and get them to move up that ladder to more expertise.
I can share that, Nightcrawler, and I'm not the person in charge of the CAD training. So actually, Ben, are you on call? I thought I saw Ben on here earlier.
Yeah, I'm here.
And do you want to share? We send them through frcdesign.org, right?
We've tried in previous years. They've actually looks like they've gotten better on the train, because it when we looked at it last year, it was way too complex for a beginning CAD student to go through, but it looks like it's better this year. What we have had our CAD students do is go through some of the Onshape modules. I believe it's Introduction to Sketching and Introduction to Part Studio. And with those two under their belt, they're able to do some simple sketching and part creation. And from there on, we've been kind of working one-on-one with them.
That's a very similar approach to how we do programming as well, where we'll send them to Codecademy. We tell all our programmers that they need to go through the first 6 lessons on Codecademy, which gets them far enough to do the things that we need to do on the robot, unless you're doing really advanced vision stuff that'll get you the basics. And then we start running them through some of our custom training that we develop that's robot specific. So very similar, run the basics using online resources, and then we try to do something more specific afterwards.
And what do you do for mechanical?
Mini trials.
Okay, so on the job, robot specific.
Similar to what is probably not nearly as structured as what Ali discussed, but similar to what Ali discussed, we take the first 2 to I think it was 3 weeks this year of tool training, and kind of what is a motor, what is, all the, what are these parts, what are they called, where do things live in the shop, how do you find them, how do you use them, things like that. And then we do mini trials. So we usually start our mini trials the 2nd or 3rd week of October. This year that coincided when the game manual was released, but if the game manual is released the October 1st, we usually do not open that manual for at least a week. And we do our training in the beginning. But yes, a lot of it, you can show somebody and you can let them drill a hole in a piece of aluminum. But until they've actually done that for a part, it probably isn't going to be sort of become muscle memory. So we give an introduction to those things, but really we rely on mini trials for a lot of the tool training.
All right, so now I could talk a little bit more about programming training on our team. So I'm one of the engineering deputies, and I was the one who ended up running the programming trainings on our team during training month in September. So our team uses Rust, which definitely makes us unique over a lot of the other teams that use Java. And it also makes definitely for a more unique training, because they can't just read the documentation for like WPI and that kind of stuff with Java. And it's just like less of a known language than Java as well. So there's a lot of training behind it. And so when we first ran our trainings during training month, we're having a lot of issues with the school and not being able to access the programming tools on our laptops. So the main training that we did is just like an intro to programming, kind of just like get them familiar with the concepts of programming and like what the sub team does on the team and how it contributes to the final product of a working and fully functioning robot. And the way that I did this was we wanted there to be an activity that was kind of like taught the basis of programming without doing programming actually, because we didn't have access to the resources at the time. So the activity that I ended up doing that was quite popular among the team was I had an activity for create a peanut butter and jelly, but not like seriously. In order to like teach kind of like thinking like a programmer and that type of like mentality, we've done an activity that some of you might have seen before, where you're supposed to write a list of instructions that are specific enough for someone to assemble a peanut butter and jelly sandwich. And then basically when you actually act out the instructions, you got to like just take them really like literally. So like if it doesn't tell you to do something, just don't do it, just as code would if you didn't tell it to do something. And then we were able to act that out with pieces of paper as bread and markers as the peanut butter and jelly. And that was a really fun activity that a lot of people really got into and kind of taught them about like a computer doesn't know anything unless you tell it, which I think was a really good training activity that got a lot of people involved.
if any teams have anything, if any teams want to share what they do for their programming training, we would love to hear about how you all train your programmers, because as you heard, we didn't have programming software for the past few months. It was blocked on our school computers. So we have not been able to teach a lot of programming other than, as Will shared, teaching the basics of how programming works and what you need to do to make code work. We haven't been able to teach a lot. So we would love to hear about how you all run teaching. Just because we're worried that's something we're going to struggle with this year, we'd love to hear about how you all run that.
Well, I've already shared how we do the intro stuff for Nightcrawler. Hopefully, while I share this next story, everyone else can think about what they want to talk about. But something that one of our programming captains did that was really unique and quite frankly, I think was brilliant a couple of years ago is they created a robot code called BuggyBot, and every single file had multiple bugs in it. And so they committed this into GitHub. It required the students to create a branch, pull the code out on their computer, and they had to fix every single bug in the robot code. I think it's the first thing that we have the students do after they've gone through the first 6 lessons on Codecademy. And so it can be anything from there's a missing semicolon or a missing curly bracket, or your else statement, your if statement has 2 else's, or things like that. Just structurally deficient, the compiler, this is never going to compile because there's syntax errors. But there might be other things in there where you're checking to see if something's greater than this or less than this, but you use the greater than sign twice, and therefore you're never actually going to fall into the next block of code type of thing. So there's also those types of issues in that code. That can be incredibly frustrating for a brand new developer to go in and see everything's red and I don't understand what's wrong here. But it's those types of things that I like to say as a developer, as a software developers, you get enough bloody noses and you remember what to look for, right? And so you get in there and you have that frustration and then you have that success of figuring it out. Those are very powerful moments for learning. And that's been, I don't know that I can say that the students enjoy that bit of training, but I do think they feel very successful having gotten out of that programming. I think that's a good one. Another piece of programming that is optional for our team, we used to make it required and now it's sort of an optional thing, is we have a dungeon crawler text adventure game that we have students make. And so the idea is that you draw a very simple map through a dungeon, and usually there's 2 or 3 rooms, and one room has the key to get out of the dungeon, and the other rooms have monsters or the exit door or something like that. And you have to write the code to tell your adventurer to go north or go south or go west. And the reason why we did that is because it's a ton of logic. There's a lot of if statements in there of, can I go north? What am I in position 3? The only place I can go in position 3 is west, or I can go west and south. And so there's a ton of logic in there, but it also is effectively a state machine. And so the idea that you're teaching programmers that if you have a very complicated intake, for example, you might say, hey, I can't bring that intake in until I've stopped the motors. And so if the driver has pushed a button that wants to retract the intake, the programmer has to think, what state am I in, and what state do I want to go to, and what are the things I have to do to get there? And that's sort of often referred to as a state machine in programming. And so it teaches students to sort of manage what is the current state, which is equivalent to saying, where is my adventurer in the dungeon, and what do they want to do? And if they want to do that, is that allowed? And how do I get them there? And so that's another one we did, but it's an optional one because it's a big one. And so not a lot of students get to the point where they can actually do that code before it's time to start working on the real robot. It's sort of the end of training if you run out of other things to do. We also do XRPs. Our XRPs are really limited to driving and autonomous. We haven't done a good job of building extra mechanisms for our XRP robots. It was a summer goal that we got okay far in, but not far enough to use as a training platform.
Yeah, that sounds really cool. Thank you for sharing. I really like the idea of the buggy bot. That sounds really useful.
Victor, do you have anything to add?
Oh yeah, I was gonna ask, is the buggy bot just like private, like only night crawlers, or like is it public?
I don't know the answer to that. Let me see if I can find it. If it's public, I will share a link.
Okay, in the meanwhile, I think we can go on to how we do design in CAD. So this year, what we did for design in CAD was during like September in our training month, we had like 30-minute sessions where we would get new students into the room, tell them about something like, how to sketch a part in Onshape or how to design a part. And then the point was that the meeting was so short that they could go home and practice it for themselves and come to the next meeting with their new designs. I guess I'd like to ask what your guys' design workflows look like, how you onboard people to CAD.
This is Scott. If that is that question directed specifically to Nightcrawler? I think we already covered. I asked for help too, so hopefully other mentors are ready to speak up on that one because what little we do, I've already shared.
You might have. I got here a bit late, so.
Oh, well then I can cover it again. We have our students go through the first two lessons of the Onshape training, so sketching and part studio. And then we have tried to use the frcdesigns.org learning modules. Ben, who's on the call here, shared that sometimes those can be a little too advanced for someone brand new into CAD. The rest of that is really going to be hands-on, where they sit side by side with a mentor or with a veteran CAD student to try to accomplish a specific goal. And it's not very well structured. It's definitely something that we need to work on.
We tried something a little different this year. This is Mark from 3926 Emperors. Just having our new students to the team with a veteran student, and he just trained them. He showed them some things in the classroom, and then he had some parts that he just had them design, and then he took their designs and 3D printed them once they designed them. But after about 2 or 3 sessions of him training them, and then him walking around with a mentor. And actually, it was mostly the student by himself was walking around and helping the students one on one or in small groups. There was only a small number of students in the room, less than 10. So we'll see how that goes. I think that we will be in the position that Scott mentioned earlier, whereas where that is, while this training was good, these students, I do not believe, if they've never seen CAD before, will be in a position to yet be independently designing things for the competition robot. But I think if they're interested and they have a mentor with them one on one, or a veteran one on one with them, like Scott Davis said, I think then there's the potential that they could be that they could contribute.
Okay, that's good to think about. I think we can go on if nobody has anything else to say.
So I'd say another training topic we want to discuss is how do you teach new students how to use tools and do like hands-on robot stuff like tools and electrical. So what we'd say is we definitely tried dedicating specific trainings to that, but we found it hard to find projects that would teach this adequately as it would be to season, because even mini trials is a very different experience than the real season is. But Talon does rely a lot on getting hands-on experience through things like mini trials. So how do you get people trained on how they would actually build a robot? Yeah, does Ben Johnson have his hand raised?
Yeah, so our students came up with something completely new this year. Rather than, we used to do things like we had them build a birdhouse or a lamp or things like that. So we actually had 2 stages of learning how to prototype. So we have a bunch of 80/20 that they put together 2 different test rigs, and they used the crescendo notes, and it's like figure out using this test rig how to find the different parameters you need to shoot this note. You know, what wheels you need to use, what compression you need, what speed you need to send it, and things like that. And then once they developed or got those skills, then they'd actually created wooden cutouts that were actually more like the prototypes that we'd use during the build season, with adjustable spacing for the bearings. And they took those numbers that they got from the 80/20 prototyping, put it together with those plates, and then we're able to see some of the processes that we went through during the build season. And they have their hands on tools, and also learning how to communicate numbers when they're prototyping. It's like, what are important things that you need to know when you're prototyping? What are important parameters that you need to find out before you can actually build something? So we think it went okay. We'll see how the season goes.
Thank you so much for sharing. Does anybody else have something? Yeah, Mark?
We tried something different this year with our new students. We had them go through training on everything. So I just mentioned CAD training. We also had them build a swerve drive base because we needed another swerve drive base. So they it was part of the challenge was making sure everybody had something productive to do. Of course, our team might not be as big as some of the other teams that are on this call, but the idea was they would build, wire, and code the swerve drive base. Of course, coding is very difficult, and they were not really able to make a lot of progress on that. But they were able to build quite a bit of it and wire a significant portion of it, or at least learn about the wiring and get a start on it with a lot of mentor guidance. That was, and in doing so, they had to use obviously a lot of the tools in the shop to cut the rails for the drive base and things like that. So everybody was trained a little bit on the tools, on the construction, and then everybody was trained uh, on the wiring to some degree. And so we wanted everybody to know a little bit about every part of the robot. And then we're dividing, then they'll divide up into sub teams, obviously, at some point.
All right. Thank you, everybody, so much for sharing about how you do training and your structures.
This is Scott. Quick. I looked through our GitHub repo. I do not know what that repository is called for the BuggyBot, but I will make an effort to figure that out and get that published on our wiki, and we'll maybe come back to that in a future episode. I did, however, find that someone recently made an update to our 2007 rack and roll game code, so not sure why that happened, but if you're interested, that repo is public if you want to see code from 2007. Very strange. Well, Allie, we've crossed the 8:30 mark. Is there anything else you wanted to cover tonight? Do you have more on your slide deck?
We appear to have run out of time, so that is all Talon will be presenting. Thank you all so much for all of your discussions on your team structure, how your team solves problems, how you all delegate all the tasks on your team through your structures, how all of your team's trainings are run, how you get all of the skills all of your students need. Those were all absolutely amazing things to hear from all of the teams there. So I just want to thank you all so much for all of your input here. And also, I just want to thank the members of my team. Thank you so much for my deputies for helping run this. And also, thank you so much, Scott, for hosting all of these every week.
And I want to thank you. All the claps are going across on the screen. Thank you so much. You guys have once again led an amazing roundtable. Lots of great discussion. We really appreciate you signing up to do this. And I look forward to the next one, maybe next fall again. You guys have got a streak going, and I really appreciate it. All right, with that, next week will be our last roundtable of the year, and then we'll take a break for between now and kickoff. We will come back on the Sunday following kickoff and talk about everything we're excited about, maybe some early ideas we might have for robots. We'll do our 2026 season kickoff as our first roundtable of the new year. So we got one more to go, and then we'll be into 2026. So again, thank you, everyone. I appreciate you joining tonight, and hopefully I'll see you next week. Bye.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.